Good morning, sir. I am B. Balaji. I am from Tripoli department. Now I am going to say about laws of illumination. And agenda overview for laws of illumination is fundamental principles of illumination and key law growing illumination and types of illumination, artificial and their applications and practical consideration in electrical lighting system. And coming to fundamental principles of illumination, the definition of importance of illumination in electrical energy utilization is illumination is the amount of light that falls on a surface essential for clear visibility. Energy efficiency benefits. There are proper illumination reduces energy wastage by optimizing light usage in electrical system and improved functionalities. The good illumination enhances the functionality and usability of spaces where light is applicable. Basic terms of illumination: luminous flux and luminous intensity and illuminates and luminance. Luminous flux is nothing but luminous flux that measures the total amount of visibility light emitted by a source in all directions. And luminous intensity quantizes the amount of light emitted in a specific direction from a source. Illuminance describes the amount of light indecent on a surface area affecting how well it is. And luminance represents the brightness perceived by the human eye from a surface or light source. And coming to units of measurements of lumen and lux and candela. Means luminous flux. The luminous quantities the total amount of visibility light emitted by a source represented luminous flux. And lux means illuminance. Lux measures illuminance or light intensity per square meter on a surface. Courier for light design. And candela, luminous intensity. Candela is the unit of luminance intensity describing the light emitted in a specific direction. And then uh, key law governing illumination. Inverse square law of illumination with formula. Inverse square law principle is illuminance that decreases inversely with the square of the distance from a point light source, illustrating light spread. Mathematical formula that is E equals to I by d square that coordinates the relationship between illuminance intensity and the distance clearly. And Lambert's cosine law with the formula. The definition of Lambert's cosine law is illuminance on a surface is directly proportional to the cosine of the indecent light angle. Mathematical formula is E equals to I by d square into cos theta. And applications of illumination laws in light designing, optimal fixing positioning and energy efficiency and glare prevention are these are the applications of illuminance law in the lighting design. And then types of artificial illuminations and their applications. Point source illumination, explanation formula and real time images. This the definition of the point source is: a point source emits light from a single localized point in space, creating focused illumination. On square law, inverse square law means that illuminance from a point source decreases proportionally to the square of the distance from the source. Examples of point sources. Common example include small bulbs and LEDs used in focused light applications. And coming to extended source of illumination, explaining formula and real time images. Extended light source of characteristics and illumination formulas and practical examples. Here we can see the extended light sources have measurable sizes and resulting in uniform illumination over an area. And formulas are used to account the source of an geometric in calculating light disturbance. These are the extended sources of illumination. And then diffused source illumination, explanation, formula, and real-time images. Diffuser light characteristics and illuminance formula and practical example. These are the parts of diffused source illumination. And diffuser light characteristics means diffused source scatter light broadly to reduce shadow and glare for even illumination. The formula accounts for diffuse reflection and scattering light to the calculate illumination accurately. And coming to practical consideration in electrical lighting system, factors of affecting illumination efficiency. There are the factors are a fixed design impact, lamp type importance, and role of reflectors, installation and maintenance. These are the factors. And selection of light source offer energy optimization, the selection of energy efficient light and maintaining illumination levels. And there are modern lightings technologies like LED smart lighting. LED means light emitting device, and smart lighting control. These are the modern techniques. And finally, the conclusion of laws of illumination is grasping illumination law helps optimize electrical systems use electrical energy use in the light applications effectively. And sustainable light solution means technology advancements enable development of a sustainable and energy efficient light source. And thank you very much, sir.